Hello and welcome back to my channel. In this video we are going to learn differentiation from first principle and as well as using other techniques to solve simple as well as complex examples. So starting with the first one, differentiating from first principle. Whenever they ask to differentiate with respect to first principle, we have to use this formula, that is f dash of x equals limit as h tends to 0 f of x plus h minus fx over h. Now how to use this formula? As you can see, there is an example over here. Prove from the first principles that the derivative of 6x is 6. So we have to prove that when we differentiate 6x, we are going to get 6, and we have to prove that using the first principle, this formula. Now what we are going to do is, we are going to take fx is equal to 6x. This is the first thing we need to do. As we can see in the formula, we have fx, we have also f of x plus h. So that means if we are replacing in place of x plus h, then wherever we have an x term, we are going to replace the x term with x plus h. This is the meaning of the f of x plus h. Now we have fx, we have f of x plus h. Now we are going to substitute these values in the formula. So we are going to write it as f dash of x equals limit as h tends to 0 f of x plus h, that is 6x plus h minus f of x. F of x we have as 6x, whole thing over h. Let us simplify this further. We get it as limit as h tends to 0. We are going to distribute this bracket and write it as 6x plus 6h minus 6x over h. So this becomes positive 6x and negative 6x cancels, and we are left with limit as h tends to 0 6h over h. Now we can also cancel the h terms, h and h, so we are left with 6. Since there is no h term in our answer, we do not have to write limit as h tends to 0. So we get f dash of x is equal to 6. This is what they had asked us to prove, that the derivative of 6x is 6. So we have used derivative of first principles to show that the derivative of 6x is 6. Now let us look at the second example. F of x equal to ax square, where a is a constant. Prove from the first principles that f dash of x is equal to 2ax. That means we have to use the first principles formula again to find the derivative of f of x, and we should get its derivative as 2ax. As we know, this is the formula for the first principles. Again, f of x is already given to us, so let us write it down. F of x is equal to ax square. So f of x is got. Next thing we need to find f of x plus h. So f of x plus h means wherever we have x in the f of x, we have to replace it by x plus h. So here it becomes a x plus h the whole square. So wherever x was there, we have changed it to x plus h the whole square. Now let me just expand it over here. This could be written as a, and we can expand this as x square plus 2 times x times h plus h square. Using the algebraic identities, we can expand this. So this becomes, after expansion, ax square plus a times 2 times x times h gives us 2ax h plus a times h square gives us ah square. So this is our f of x plus h. Now let us put these two values in the formula. We get it as f dash of x is equal to limit as h tends to 0. We have f of x plus h as ax square plus 2ax h plus ah square, and then we have f of x as ax square, so minus ax square divided by h. Now let us further simplify this. We can see that plus ax square and minus ax square gets cancelled. So we are left with f dash of x equals limit as h tends to 0. We can take the h term common from these two terms. So we have h common, and the left terms are 2ax plus ah. This is what remains in the bracket when we take the h terms common out of these two. This thing is divided by h, which is present here. Now again we can see h and h gets cancelled, so we are left with limit as h tends to 0 2ax plus ah. Now here we are left with h term. As we can see, h is tending towards 0. We can assume here that h has become equal to 0. Means it has been approaching very near to 0. So we can say that h is equal to 0. So here what we are going to do is, in place of h we can replace it with 0. So we get it as 2ax, and this term becomes 0 because a times 0 is 0. And since we have no more h terms left, we do not have to write the limit term. So we get the differentiation of fx, which was given as ax square, as 2ax from the first principles. This is what is being proved. Now let us try to differentiate expressions having two or more terms. Find the gradient of the curve with equation y equal to f of x at the point A, where f of x is equal to 3x square plus 2x raised to negative 1. Whenever they will ask you to find the gradient of the curve, it means they are asking you to differentiate the given expression. Here the given expression to us is f of x is equal to 3x square plus 2x to the power of negative 1. If we want to differentiate this, there is a general formula for differentiation. If we are giving an expression f of x equals x to the power of n, so when we differentiate this term, we get it as the power comes down and is raised to the power of n minus 1, means the power of x is reduced by 1. So let us try to use this formula and differentiate the given term. So here we have f dash of x equals 3 stays the same. As we saw, the power comes down for x. So here the power of x is 2, so it comes down and x is reduced by a power 1. So it becomes 2 minus 1 plus 2. The power comes down, it becomes negative 1, x to the power of negative 1, and again it is reduced by a 1, negative 1. So we get it as 3 times 2 is 6, x to the power of 1, and plus 2 times minus 1 gives you minus 2, x to the power of minus 2. Minus 1 is minus 2. Now they have told us to find the gradient of the curve. So we have found out the gradient of the curve by differentiating it. But if we want to find out what is the exact value of the gradient at point A, we have to substitute the value of x as 2. So wherever we have got x value in the gradient, there we are going to substitute 2. So f dash at point 2, that is gradient at point 2, is equal to 6 times 2 minus 2, 2 to the power of negative 2. This gives us 12 minus 2 times 1 over 4. So let us check how much we get this. We get it as 12 minus 2 over 4. So solving this, we have 2 1 times, 2 2 times. We get, taking the common LCM. So here we have 2 and here we have 1. So it is 24 over 2 minus 1 over 2. It gives us 23 over 2. This, when we divide 23 by 2, we get it as 11.5. So the gradient of the curve at point A is 11.5. Let us look at another example. Find the points on the curve with equation y equal to f of x, where the gradient is 0 and f of x is equal to x raised to 3 over 2 minus 6x plus 1. Again we are going to use the differentiation here, but they have said the gradient is 0. That means when we differentiate fx, that is f dash of x, that should be equated equal to 0. After equating it equal to 0, we are going to get the points on the curve. So what we are going to do here is, we are going to differentiate this expression. So f dash of x is equal to x to the power of 3 over 2 could be written as 3 over 2, the power comes down, and x is reduced by 1. So x raised to 3 over 2 minus 1 minus 6, x is raised to the power of 1 here, so we write times 1, x is again reduced by 1, so 1 minus 1, and differentiation of a constant term is 0. Remember, the differentiation of a constant term like 1, 2, 100, 1000, whatever, if it is a constant number, then its differentiation is going down to 0. So here we get 3 over 2 and x, here 3 over 2 minus 1 gives you 1 over 2. Then here minus 6 times 1 is 6, and x to the power of 1 minus 1 is x to the power of 0, and x to the power of 0 is 1 itself. So we get this term. Now as we have seen, gradient should be 0. That means whatever f dash of x we got here, we should equate it equal to 0 now. So we get 3 over 2 x to the power of half. We can take this minus 6 on the other side, so it becomes equal to 6. Now we are going to take the 2 on the other side, so it becomes 3 x to the power of half equals, this becomes 2 times 6 or 6 times 2, it's one and the same, is equal to 12. So we have 3x raised to 1 over 2 equal to 12. So we get now x to the power of half is equal to 12 divided by 3, which is equal to 4. Now to solve this x to the power of half, remember the laws of indices. So if we want to send the power on the other side of equal to sign, then it reciprocates, means 1 over 2 becomes 2 over 1 when it jumps on the other side. So we have x is equal to 4 squared, which is nothing but 16. So it means that at x equal to 16, we have the gradient 0. So we have got the point on the curve as x equal to 16. Now let us try to differentiate some simple equations using the above rules and formulae we just learned. This is, we have to differentiate f of x equal to x raised to minus 1 plus 4x. So let us try to differentiate it. F dash of x is equal to, we know that we have to get the power down, so it becomes negative 1, and x is reduced by a power 1, so it becomes minus 1 plus, keep the 4 same way. Here x to the power of 1, so 1 comes down and x is again reduced by 1. So the power of x is reduced by 1. Here we have minus 1 x to the power of minus 2 plus 4 times 1 is 4 x to the power of 0. We can further simplify this as minus 1 over x to the power of positive 2 plus 4, because x raised to 0 is 1. And here if we want the power of x to be positive, we take the reciprocal of this term, so it becomes 1 over x square. This is the differentiation of this term, and this is how we differentiate it. Let us try a few more examples. Here they have told us to differentiate 3 over x square. So we have 3 over x square. We will write it as 3 into x to the power of negative 2. I will take the x on the numerator, so the positive power changes to negative power. Now I am going to differentiate it. So let me take first y equals 3x to the power of minus 2. Now I am going to differentiate it as y dash. Remember, we can write the differentiation as f dash of x, or we can write it as y dash, or we can also write it as dy by dx. All the terms are same, asking us to differentiate the given terms. So here I am going to take it as y dash equals 3. We know that the power of x comes down, it becomes minus 2, x raised to minus 2, and the power of x is again reduced by 1. So we get it as 3 times minus 2 is minus 6, x to the power of minus 3. And if we want to write it as a positive power, as you know, we have to just reciprocate it, and the x term in the numerator goes to the denominator and becomes a positive power. This is how we differentiate it. let us consider one more example. Here you can see there are multiple terms over here. So what we are going to do is, let me take this as y equal to, so y equals, I am going to open up the brackets, expand the brackets and distribute the terms. So here the first term becomes 1 over 3 x cubed times x. I can write it as 1 over 3 x to the power of 4 minus 1 over 3 x cubed times 2 gives us 2 over 3 x cubed. Now we have to start the differentiation of these terms. So we have y dash equals 1 over 3. As we know, the power comes down 4 and the power of x is reduced by 1. Same thing we have to do for the next term, minus 2 over 3. The power comes down and x's power is reduced by 1 again. So here it becomes 4 over 3 x cube, and here we can cancel off 3 and 3. So we are left with minus 2 x to the power of 2. This is the differentiation of these kind of examples. So open up the brackets, expand them and then differentiate them. This is another kind of example where they will have asked you to differentiate this term. As you can see, there is x term in the numerator as well as in the denominator. So we have to follow certain different steps here. So let me show you one by one how to do it. Let me first consider the given expression as y. Now we know that square root of x can be written as x to the power of half. Making use of this, I am going to solve the given expression. So I will write it as y equals 2x cube plus 3x over x to the power of half. Now I can split the denominator among the numerators, which means I write it as 2x cube over x to the power of half plus 3x over x to the power of half. So I am giving the denominator to each term in the numerator. Next, using the rules of indices, that is, if I am writing a term as a raised to m over a raised to n, I can use it as a to the power of m minus n, given the fact both the numerator and denominator should have a. Here if you see, I will write 2 the same way, and x and x are same as we had a and a same here. So I can write here x and I can subtract the powers as 3 minus 1 over 2 using the laws of indices. Next, for the second term I am going to do the same thing. 3 stays the same and I have here x to the power of 1. If no power is given for the x, it means it has a default a power of 1. So I am going to write it as x raised to the power of 1 minus half. So 1 minus half, the powers will get subtracted. So here I have 2 x to the power of 3 minus half gives us 5 over 2 plus 3 x to the power of 1 minus half gives us half. Now I have got a y term which is as much simplified as possible. Now I am going to differentiate it. So it becomes y dash equals 2, the power of x comes down, so it becomes 5 over 2. So 2 is multiplied with 5 over 2. times x 5 over 2. Now we are going to reduce the power by 1 because we are differentiating it. Plus 3, the power comes down, so 3 multiplies with half times x to the power of half minus 1. Now further simplifying it, 2 1 times, 2 1 times, you can cancel them as 1 2 is in the numerator and 1 2 is in the denominator. So we are left with 5 x to the power of 5 over 2 minus 1 gives you 3 over 2, and plus 3 into 1 over 2 is 3 over 2, x to the power of 1 over 2 minus 1 x raised to minus half. So again the power of x we have got it as negative here. So if we want to change it to positive power, as you know what we need to do, we need to bring the x to the denominator. We need to reciprocate it and we get the positive power. This is how we solve these kind of examples. Now let us consider another type of example where they have asked us to differentiate the given expression. As you can see, we have two brackets which we need to expand. So let us expand it one by one. So starting with 3x times 4x. So 3x times 4x gives us 12x square. So we have got the first term as 12x square. Now let us multiply 3x with 1 over x. So we have 3x multiplied with 1 over x. We can clearly see that the x terms and x term gets cancelled. So we are left with only 3. So we write the next term as plus 3. Let us multiply negative 2 with positive 4x. So we have negative 2 multiplied with positive 4x. So we get here as negative 8x. So we have our next term as negative 8x. Finally, we have to multiply negative 2 with 1 over x. So we have negative 2 multiplied with 1 over x. So we get it as negative 2 over x. So let us write it here as negative 2 over x. Now this expression, whatever we have got, let us take it as y equals. I am going to take this x term on the numerator. So I can write it as y equals 12x square plus 3 minus 8x minus 2 x to the power of negative 1. So if I am taking the x on the top, the positive power changes to negative power. Now I am going to differentiate it. So y dash equals 12. The power of x comes down, so it is times 2 into x to the power of 2 minus 1. The power reduces by 1. Plus 3. Now as I had mentioned earlier, the differentiation of any constant term is going to be 0. So we get the differentiation of 3 as 0. Minus 8. This is x to the power of 1. So we have 1 here and power of x reduces by 1. Minus 2. The power of x comes down, negative 1, and x to the power of negative 1, negative 1. So the power of x reduces by 1. So we get here as 12 times 2 is 24 and x raised to 2 minus 1 is 1 minus 8 x to the power of 1 minus 1 means x to the power of 0, which is 1 again. So here we can just write it as into 1, and here negative 2 times negative 1 gives us positive 2, and x becomes negative 1, negative 1 is negative 2. So we can write it as 24 x minus 8, and since it is a negative power, we can again change it to positive power by sending the x to the denominator. This is the differentiation of the given expression.